Okay, just a review. We have finished addition formula, okay, which is chapter 11.3 for A Maths. We have finished all this. We have finished the pop quiz also, and today I'm going to start on a brand new concept. Okay, now this concept is very useful and is very commonly tested in the exam, as I mentioned in the last lesson, more so than this addition formula. Okay, so this one you need to know lah. Okay, so what is this double angle? Now, why is it called double angle? Okay, now you know that sine. I'm here now. Sine of, let's say, 2a, right? This 2a will be an angle, or what we call the argument. Okay, so sine 2a is equals to 2 times sine a times cos a. Now, can you see that if you were to compare this angle with this angle, okay, or for that matter this angle, then this angle is twice of this angle, correct? That's why we call it double angle. Alright, and this will be given in your formula sheet in your examination. Okay, we have done this already. We have over the past week done this addition formula, and now we are doing this. Okay, and after I've done this, right, you will mark the end of trigo for A Maths. Okay, so we are nearing the end. Now let me go through the first one for double angle for sine first. So let's say I have sine 30 degrees. Okay, another way to write sine 30 degrees is to write it in this form, 2 sine. So it is twice of this, right? This must be half of this, right? So it'll be 15 and then sine, cos 15. Okay, so that's how you use the formula. Of course, in this particular case, right, it's not very useful to express this as this. Not very useful, right? But let's say I give you another one. Let's say sine of, let's say 60 lah, okay. You know that, okay, there's no dot here. Okay, 60 degrees. You know that I can express this as 2 sine 30 degrees, then cos 30 degrees. Okay, this might be more useful than this because these are all special angles, special angle, special angle. Okay, now of course the question may not be like that lah. The question may be in terms of algebra. So for example, they say sine 4x. Now, then you ask me, sine 4x, but down here there's only 2. There's only 2 here. There's no 4 here. Yeah. So that's the power or flexibility of this formulae, okay, or formula. This one, right, you can write it as sine 2 sine half of this, so it'll be 2x, and then half of this, so it'll be cos 2x. Okay, so that is the usefulness of this double angle formula. Okay, and further to this, you can also still express this as, okay, normally they won't ask you to do that, but I'm just trying to tell you, right, this one is twice of this angle, right? So this will be, oops, miss out the 2. So this is this, and this fella, okay, now this is something, it's also double angle. You see, it's found here, but I just want to tell you that just want to tell you that this double angle for cosine, there are 1, 2, 3 different ways to express it. Okay, why 3 different ways? Later I'll explain. Okay, but down here, right, I can either write it as because cos 2a, cos 2a, cos 2x, I can change this to x. That means I can either write it as cos square x minus sine square x, or okay, of course the front is the same, this part is the same, okay? Or I can write it as 2 cos square x minus 1. This and this, they are both the same. That means they are equivalent. Or I can write it as 1 minus 2 sine square x. Yeah. Okay? So this is how I can use this double angle for cosine. Okay? Now, which one to use depends on the question. It can be a proving question like the one that I'm going to show you later. Something like that. Okay? Then which one to use for cosine, right? See cosine, cosine here. Let me copy this over. For cosine, there are 1, 2, 3 different ways to write it. You only write one, you don't have to write all three. So which one to use? That's where you need to observe that. Okay, I straight away go to the proving, okay, since I'm already at this question. Okay, later then I elaborate on how we get these 3 different forms, 1, 2, 3 of cosine 2a, okay? Now, this is a proving question. Let me write it down here. They want you to prove that the left hand side is equal to the right hand side. Now remember, I always say try to work with the more complicated side, right? And in this particular question, the left hand side happens to be the more complicated. Normally in O level, right, is proof left to right. Okay? They won't really make things difficult for you. Let me see how to get rid of this. Close, is it? Okay. Now, how do I start? Notice that the right hand side, right, is made up of only cos over sine, because cotangent is cos over sine, right? So you must have what I call the end in mind. In the end, your this left hand side, right, which is this fella, okay, must be equals to your right hand side, which is cotangent x. But cotangent x you learn from before your end of year exam. We learned this, right? Cosine x, cotangent x is cos over sine, right? Okay? That means you must try to work this whole thing out, right? Such that you end up with only cosine at the numerator, sine at the denominator. Okay, but now we have a problem, you see. Sine we actually have, but there's another sine 2x here. That's a problem. Okay, then the cosine actually we have, but there's a 1 and there's this thing here, cos 2x. Okay, so you see, this cos 2x, right? If I change it to this, not much use, because I make this whole thing even more complicated, the numerator. Can you see that? So I don't use this. Okay, now if I take 2 cos square a minus 1, maybe this minus 1 is useful because it will help me cancel off this 1 here. Okay, so that's what I'm going to do. This front part, I don't do anything first because I can't do anything also. But this cos 2x, right, I'll change it to, see cos 2x, I change this to x. So it's plus 2 cos square x minus 1. Okay, why is this useful? 1 minus 1 will cancel out. Then you will tell me, but no use what? There's still cos x, 2 cos square x. Okay, don't worry. Hold your horses. Wait first. Why wait first? Because at the denominator, I also have sine 2x. There. I can use this to change this to 2 sine x cos x. This is this. Okay? Then you ask me what's the use. Don't worry, you do first. We settle the top first. The top now is it has become simpler already, like that. The bottom, the denominator, also is something like that. But okay, you see denominator I got sine x here, I got sine x here. I take out sine x. Because you see ultimately I want sine x at the denominator. So I don't mind taking out the sine x as the common factor. Okay, see carefully This times this is this. This times this is this. So perfectly okay. Then now you see ladies and gentlemen, don't blink don't blink. I'm going to do magic. You see I want cos on top, right? Okay there's a cos here, I take out. Then you see, this is how beautiful mathematics is. What you want, you keep. I want this, you see? I want this, you keep. This fella automatically, right, when you take out common factor, they will cancel out, then become this. Then you can get this, finish. Okay? Did you understand? So this is how you do proving of this particular question. Okay? Alright, I will stop here. You try to digest this. Digest what? Digest, this is what we call the double angle formulae. Why? Because this angle is double of these angles. This angle is double of these angles. This angle is double of these angles. This angle is double of this angle. Okay? Yeah, so for cosine, for sine, for sine is very straightforward. There's only one formula. Tangent also one formula only, nothing much, no big deal. Okay, I'll go deeper in depth tangent next time. Cosine, there are 1, 2, 3. Now, why is it that there are 3? Okay, by the way, I finished this question already. Some of you may think, finish already. We already showed this already. Finish. Okay, so you see how simple additional mathematics is. Okay. Of course, you need to know how to factorize and all that, your lower set work. Okay, now, why is it that cos 2a, right, can be this, can be this, can be this? Okay, I show you why. Now, the first reason is, ladies and gentlemen, due to this fella. What fella? You look at your formula sheet. This one. Very commonly used one, right? Sine square A, I can change it as 1 minus cos square A, right? Okay, so I'm going to do this. Okay, I write it on the notes here. The thing that I showed you just now was sine square A plus cos square A equals to 1, right? So if I want to make, I make this the subject first. If I want to make this the subject, then, ladies and gentlemen, it will become 1 minus sine square A. But already there was this fella here just now, right? And it's still around, right? So it is 1 minus 2 sine square A. There. That's why this and this are equal. That's why this equal this, then this equal this. Finish. Okay? Then you ask me, okay. Then how I get this? Very simple. Very simple. It's the same Mathematics is all about pattern. Just now we change this, right? Cos square A, right? Okay, now we don't change cos square A. Now we change this fella, to be fair. Now we change sine square A. So now I make this fella the subject. If this fella is the subject, then this fella will be equals to 1. Okay, must put bracket. You see, you don't put bracket, then wrong already. You must put 1 minus cos square A. Then you get this will be cos square A minus 1 plus. You see minus times minus is plus, right? Then you get 2 cos square A minus 1. You see? Same. Ladies and gentlemen, same. Okay, today we will end here. Thank you very much. Wait. Those who can, you see we have finished this 1 question out of 7 questions. Okay, very, very slow and steady. Okay, you can go and try all these. Okay, I'll go through next lesson. Thank you.